The graph of a polynomial function has the following x-intercepts: 0, 1, 3, and 6. Which of these expressions represents such a function? Well, just a reminder, and I won't work out all of these, but if we start with letter A, what we would do is we would take x minus 1, and we'd set it equal to 0. So we would add 1 to both sides, and we get x equals 1. We do the same thing for the x minus 3. We'd set it equal to 0 and add 3 to both sides. We get x equals 3. And finally, with the x minus 6 equal to 0, we add 6 to both sides, so we get x equals 6. Well, the thing is, that takes care of the 1 and the 3 and the 6, but we also have that 0. So it cannot be this one. And in fact, as we look down here, this has 1 parentheses, 2 parentheses, 3 parentheses. We have 4 answers, so it's got to be one of the following. And based on what we did here with the a's, x minus 1 equals 0, that gave us the right value of 1. And x minus 3 gave us the right value of 3. And x minus 6 gave us the right value of 6. So if we take the 2x and set it equal to 0, will we get x equals 0? And we do. So our answer here is 0. Just as an aside, if you're going, what? If you take this first value right here, remember x plus 1 equals 0, you would have to subtract 1 from both sides, and you would get a root of negative 1 instead of positive 1, which is why it is not the answer B, but it is D. If we look at number 10, which graph represents a parabola whose corresponding quadratic equation? So a parabola is a quadratic, and it has imaginary roots. Well, if you remember, what happens with imaginary roots is we cannot see any x-intercepts. So we can see an x-intercept on B, we can see 2 x-intercepts on C, and we can see 2 x-intercepts on D. The only one where we can't identify x-intercepts is letter A. Number 11, what is the maximum number of real roots the equations have of 3x to the 7th minus 2x to the 5th minus 10x plus 6? Well, this is in standard form, by the way, and it's going to be our highest exponent, and our highest exponent is 7, so we have 7 roots. Number 12, similar to number 9, we're given the roots this time, so this time we're going to go and say, well, x equals negative 2, and x equals 3, so we want to write the equation so we can add 2 to both sides, so we're going to have x plus 2, and we can subtract 3 from both sides, and we have x minus 3, and then we look up above and we see x plus 2 times x minus 3 is letter B. Finally, on this last one, it says which of the following is not a solution to the function? Well, we set negative x equal to 0 because the 5 is a multiplicity. We're going to set x minus 2 equal to 0. We're going to set x plus 2 equal to 0, and we're going to set x minus 3 equal to 0. But what we get, and again, even if you did negative x to the 5th, but I'll just do negative x equals 0. We divide both sides by negative 1, we get x equals 0. So, which 0 is an answer. So, the question says which one is not a solution to the function. If we take x minus 2 and set it equal to 0, then we add 2 to both sides. Well, there's that. So we're looking for something that's not. Same idea here with the x minus 3 equals 0. We get x equals 3. And I skipped one, and it must have been just subliminal, but I skipped the x plus 2, but I did this one, x minus 2, I did x, and I did x minus 3. I should have done the x plus 2, but the only answer that we haven't found is letter A. Negative 5 is not a solution to this function. One other way that you could have done number 13, conceivably, is type that whole function into your calculator and look and see what the roots are. And then you might have been able to identify the fact that -5 was not a solution.